Hello once again, class, and welcome to another mock lecture. In this episode, we are going to be talking about the area of a sector. So let's start off by talking about what even is a sector. It's a slice of pizza, right? A slice of the pie. Basically, that's what a sector is. Piece of the pie chart, if you will. The derivation of the formula starts with examining the area of a full circle, which we know to be pi r squared, and then we have to ask ourselves, well, what percentage of the overall circle is this slice of pie? To figure that out, all you need to do is take your angle measurement and divide that by 360, or divide it by 2 pi if we're working with radians. That's going to give you a percentage, right? If you score 60 points on a 100-point quiz, then you take 60, you divide it by 100, and you get 0.6, right? So 60%, right, is what you end up with. So this is going to give us a percent decimal for how much of the pie we're looking for the area for. So you're going to take that percentage and just multiply it by pi r squared. So theta divided by 2 pi times pi r squared. Some stuff cancels, namely the pi's cancel. And then you get 1/2 r squared theta. I did a little bit of rearranging here since this is the way the formula is given, but essentially it's the same thing. When the pi cancels, you get theta over 2r squared. Just rearrange the variables and you'll get 1/2 r squared theta. So that is the formula, right, for sector area. Sector area formula, A is equal to 1/2 r squared theta. And just like tangential velocity and arc length, you want the theta measurement to be in radians for this to come out correctly. So example 1, super basic example. Find the area of the sector below. It looks like we have a radius of a foot, 12 inches, and then the central angle is 97 degrees. First thing we got to do is turn that into radians. So 97 times pi over 180 is 1.693 radians. You plug it into the formula. You plug 12 in there as well. Really just kind of plug and chug mode. Not a whole lot going on. Pretty basic example. Okay, don't forget your units. Now we're talking about an area, so it's inches squared instead of just a linear distance. Okay, example 2, a little bit more complicated. Let's say that we're engineers and we've created a robotic arm that has a 125-degree range of motion, and it can vary its length between 5 and 22 inches. What I want to find out is what's the area of the arm's workspace, right? So what's the amount of space that this arm can cover if it can extend or retract to 5 and 22 inches between those lengths, and then also it's got a 125-degree range of motion. So here's kind of the picture for what's going on. This is the picture of where it's at its longest. But essentially, you're creating like this section of a donut, right? It's not a full donut, right? Where we've just like cut, you're splitting it amongst 3 kids or something, or yourself. I mean, I eat donuts all the time. But anyway, you're cutting it up, and so you're creating this kind of half a rainbow sort of looking shape. Okay? So if we draw the picture for this thing, really what we're doing is we're finding 2 different sector areas. We've got the sector area for when the radius is 22 inches, but then we want to subtract away the sector area when the radius is 5 inches, because we only want to get this shape, right? If we only want to produce this shape here, we're going to find this whole shape and then subtract away this specific sector area there. Okay, so that's going to give us this shape. So we just have to use the sector area formula twice. Okay, so first things first, we got to have to turn everything into radians. So 125 degrees times pi over 180 is 25 pi over 36. So the first formula, right, where the radius is 22, you got 22 squared, taking a half of that, and you're multiplying it by 25 pi over 36. That's a lot of pi's over 18, 3,025 pi over 18. The second sector has a radius of only 5, so you do 1/2 5 squared, which is 25, times another 25 pi, so you get 625 over 72 pi. And we're subtracting those 2 areas, right? So here's the subtraction. I went ahead and found that in terms of an actual decimal, though, because this, if you're giving someone this measurement, that might not make a lot of sense. At least for me, it's not very intuitive. Well, how many square inches is that? I don't know. So I just multiplied 11,475 over 72 by pi, and you get about 500.7 inches squared. And that's it. Very short video. Hopefully you guys found this helpful. If you have any questions, please shoot me an email. Thanks a ton for watching, and I'll see you in the next one.